Okay, so this lesson is going to be on finding covalent formulas. We'll cover that up. We don't need it. Okay, covalent formulas are a little different than finding ionic ones. The problem is that for an ionic compound, a given element is probably going to take a particular charge, right? So if I have a magnesium atom, I know it's going to have a +2 charge. And if I have a fluorine atom, I know it's going to have a -1 charge. So I can find the one and only compound that would come out of those two elements. So if I tell someone that I have magnesium fluoride, they can find that compound formula. But if I have carbon and hydrogen, there are an infinite number of compounds that those two things can form, depending on how many carbon atoms and what they're doing. The same thing is true for like a nitrogen and an oxygen. There may only be a few nonmetals, but they can bond in different ways and in different forms. So it's not as easy as simply knowing the elements to figure out what the compound is, which works in our favor because we don't have to, if we just know the elements, we don't know the compound. So in order to communicate with someone else what the compound formula is going to be, you kind of have to tell them point blank. So when we name these things, we don't assume that you know that you're going to have one magnesium for every fluorine like we did with the ionic. We have no idea how many carbon atoms per nitrogen atom they're going to be in the specific compound, so we just have to tell them that. Which means that when we do covalent formulas, instead of like having to figure it out ourselves, we have a pattern to the names for covalent compounds. That pattern goes prefix, which you learned earlier, elements, and then another prefix, element, IDE. The hardest thing to deal with when we learn covalent compounds is that there's no switching. We switched oxidation numbers when we did the ionic compounds. We had to draw our arrows, right? We had to draw that X. You don't have to do that for covalent. This prefix tells you how many atoms of this element you have, and this prefix tells you how many elements of this atom you have. And then we end the whole thing in an IDE just to make it sound like a compound name. Okay, so let's try it. For example, if I had a compound that was named tetranitrogen hexasulfide, right, I can break that whole thing down into a prefix. Here, we'll separate it. A prefix, an element, another prefix, okay, most of an element with the suffix IDE. Okay, so this compound, okay, is going to be nitrogen, okay, with 4 atoms, because tetra is 4. And then we'll have the sulf, that's sulfur, right? Okay, and hex means 6. Okay, so again, no switching. This name simply says there are 4 nitrogen atoms and 6 sulfur atoms in a compound. That's what this IDE tells me, is that I'm not just dealing with 4 random nitrogen and 6 random sulfur. Remember, just like in our ionic compound, every compound name you're going to see has 2 words. Okay, so tetranitrogen hexasulfide. Okay, so let's try some more. So if I had sulfur trihydride, right? Now, you'll notice that there's not a prefix here. We never start the name with a mono. We might put a mono here, but we won't start the name right here with a mono. If there's nothing here, there's just simply one of them, S. Trihydride, well, right, that's going to be hydrogen. That's the closest thing we've got, okay? And I simply have 3 of them. That's all there is to these things. Do a couple more. Okay, so again, carbon tetranitride, I have carbon, no prefix, so that means 1. Tetranitride, that means N, and I have tetra means 4 of them. Okay, and diboron heptaphosphide means we're going to have boron, but there's 2 of them. Phosphide, we'll go with phosphorus, and hepta means 7. And that is all there is to finding formulas for covalent compounds.